Welcome to Life Made Up of Questions. Today, our guest is Dr. Sridhara, Vice Chancellor, Hindustan Institute of Technology and Science, Chennai. So I wholeheartedly welcome you, sir, to this forum, Life Made Up of Questions.
Thank you very much. Thank you for inviting me to join this conversation.
Yeah. So before going to this session, I would like to have a detailing about our resource person. Dr. Sridhara received his PhD and Masters in Aerospace Engineering from the prestigious institute, Indian Institute of Science, Bangalore, Bachelor's in Mechanical Engineering from Bangalore University. His research interests include fluid dynamics, heat transfer, thermodynamics, turbo machinery, automotive powertrains, hybrid electric vehicles, computational fluid dynamics. His work experience includes lecturer, assistant professor, professor, dean, principal, director, executive council member of university, a total of 32 years of service in teaching, including 20 years of research, 13 years of administration. The work administration included setting academic standards and procedures, admission and other administrative works, then mentoring fellow colleagues, development of curriculum, student admission, served as member of chairman of several boards of university and engineering colleges. His academic excellence include, he has guided around 8 PhD scholars, supervised 25 theses at PG and 60 theses at UG level, reviewer of international journal Energy Reports and Journal of Applied Fluid Mechanics. His publications includes 2 textbooks, more than 150 journals and conference publications. Professional body membership includes Indian Society of Technical Education, Institute of Engineers, Combustion Institute India, Aeronautical Society of India, Institute of Engineers India, member of Research Innovation Committee and Quality Assurance Committee, and Association of Universities of Asia and Pacific. Professional training delivered includes many corporates such as GM, GE, M&M, Bosch, Tata Motors, etc., and DRDO in various topics such as automotive powertrain, thermal engineering, heat transfer solutions, CFD, fluid flow through turbo machines, etc. Delivered training to many institutes on OBE, Blooms, and accreditation, that's NB and NAC. His awards includes Best Engineering College Principal at national and state level, honored by Indian Society of Technical Education and Visheshwara Technological University, respectively, and Vocational Excellence Award by Rotary International. Lifetime Achievement Award accorded by UNICEF India, Indian Technology Congress and Committee for Space Program Development, Serbia. So thank you, sir. Thank you for being with us for today in this forum, Life Made Up of Questions. So I consider it will be a valuable session, like interacting our vision and forecasting of the current education scenario. So welcome you, sir. Welcome you.
Thank you very much for that introduction. So we can start our conversation, sir.
Yes, sir. So let's start with the new education policy. All are confused. We know what is new education policy, what are the objectives and vision of new education policy. So how this new education policy is going to help institutes, universities, then autonomous institutes, and what are the challenges, what will be the challenges for the institutes, and what are the benefits for the institutes as well as the students?
Yeah, basically, as you said, NEP is not being well understood by many people. Although all the the guidelines and everything has been published well in advance, and also nearly about 2 years it was being debated and workshops have been conducted, etc., and so on. And apart from that, unfortunately, there are political, the agendas also coming in between, and all this actually made it appear as a highly controversial. Today, we will focus at some of those good points of NEP, and also there are some challenges, as you mentioned. First thing is actually NEP says that they want to give an inclusive knowledge and skill to everyone. Basically, as I understand, the more of emphasis has been given for the skill development along with the knowledge. And therefore, NEP says that from the primary school itself, which we call kindergarten, they are looking for experiential learning, and they have actually given about 40 to 50% of total weightage, the total curriculum development. It is actually led to with skills only, more than the knowledge. So that is why NEP says even under primary school and high schools, vocational training is mandatory. For example, the students actually learning about carpentry, learning about daily household work, and similarly some other skills, etc., and so on. They are encouraging from the primary schools itself. This is one very good intention. And also there is one more thing which actually says regarding the primary education. It says that you have to use the local expertise maybe a carpenter or maybe a tailor or etc., and invite them to the schools and educate the school children to learn those skills. So there are two things actually happening in this. Number one, the kids start engaging themselves in such skills, and they pick up the skills. Number one, and number two, they start actually respecting those professionals whom we actually sometimes look down in the society. The students actually learn respecting them. This is a very good intention of our NEP, that you have to bring an inclusive. Second one is basically improving the morality among the students and bringing them a knowledge and also a feeling of belongingness. They say that every student should be given a knowledge and also a sort of understanding that we are all Indians, and try to understand more of Indian culture and as well as respect Indian heritage. So this is another very good intention of NEP, which actually it is going through. So although we are studying, using all the modern tools, the majority of them are coming from abroad or something like that. We should not lose our root, and we should never forget our root. That is the whole idea with NEP, how they started our primary school education and so on. The third point is actually there are some structural changes which has been proposed to make sure that the kindergarten is now regularized. In the sense, earlier kindergarten was being mooted by only private institutions, and it was not available in the government institutions. We had something called Anganwadi. Now these Anganwadis are converted to schools. So there are two advantages with this, because the moment we recognize Anganwadi as a school, the Anganwadi teachers or the the volunteers also will be considered as teachers, and therefore their payment will be better, and they get motivated, and lot more fund will be flowing through that. Anganwadis have been actually playing a very good role, especially in the villages, where the women folk actually go for early morning for other work, field work, etc., and so on, and nobody will be there to take care of the children. Now these children are nurtured in the Anganwadi centers by Anganwadi teachers who are not much actually trained. They were just like dadis. Now there's a proposition for also the training of these people, so that you will actually inculcate a sort of very good morality and moral values in the children through these Anganwadi teachers. So that is second part. Now coming to the higher education, which you mentioned, the structural parts are completely changing now. So far, when I come to the higher education, we were looking at the universities, something like central universities, state universities, both are government funded and government affiliated, and also we also see what is called state private universities, and again deemed to be universities. This deemed to be universities is a word which was actually coined earlier to make sure that some sort of autonomy is given for the institutions who are performing very well. Now this deemed to be university, the nomenclature itself is creating a lot of problems. The major problem which actually we find is the moment our students go abroad, what do you mean by deemed to be university? It means that you are not from a university. So neither we are, deemed to university students are actually considered as affiliated college students or a full-fledged university students. And same thing so for the faculty who are working in it. Now NEP says that there will be nothing like deemed university. All universities will be called universities. That's number one. But they are not forgotten the intention of bringing in deemed to be university. The intention was to bring in autonomy and also give sort of liberty for the institutions to have their own curriculum, their own assessment, etc. But they are very cautious. NEP says that an institution actually going through some of the accreditation processes, and if these institutions gain some scores or score something which is actually something like NAC A grade, INR within 100, etc., such institutions, even if they are affiliated, they'll be called as autonomous institutions, or they can apply for autonomous institution status, which will be granted by that particular affiliated university. And gradually, within 15-20 years, all the institutions of such cadre should become independent universities. Now, there is a lot of discussions going on this. Suppose you have too many universities existing in a state or in a country, what will happen to the status if such university closed down by any chance? So that is one debatable question, and there are positives and negatives to answer for it. For example, a university, when it is actually being recognized, it has gone through a lot of phases, starting from its affiliated college, etc., and so on. So to reach that, it would have taken lot much of experiential learning, it would have happened and then they would have reached. And I don't think any of the university will ditch down itself by after reaching a university status. They would like to retain that. And today it is a highly competitive world. Every institution would like to be within 1 in 100 of NIRF or 1 in 50, etc. and so on. So I don't think this will happen. But anyway, it's an imaginary question. Even if we consider it's imaginary question, what is the solution that NEP says? All these universities are affiliated or registered with UGC. So UGC will have all records, including the students, the grades, etc. and so on. That is where they brought a concept called Academic Bank of Credits, ABC. Every student who is studying in such university, his credit, the grade sheets are completely be stored centrally in the Academic Bank of Credit. So there are two advantages. Even if these universities lose themselves with the time, this marks or whatever has been stored, etc., would be safely stored under the government agency, that is UGC. That is number one. Number two, the students actually can also move horizontally and vertically, keeping these particular credits which they have already accrued. See, for example, a student who is studying in my institution, maybe for about first year, and he credits or he audits about 12 subjects, let me say, in a year. All these 12 subjects or courses credits will be banked with Academic Bank of Credit by our university, and the student will be in charge of adding, and as well as university will be in charge of verifying it. After verifying, this becomes a permanent record. By any chance, if the student thinks that okay, he cannot continue the studies immediately, he can take a break, and the break can be up to 7 years. But in between, actually, he can rejoin the same institute, or he can go to some other institute also, and then continue his studies. So these credits will be transferred to him as the credits he has already earned. And there is one more thing actually, when I said horizontal, a student who joins a particular stream of engineering, as an example, if I take, can change over his course of understanding or learning even at a later stage. See, for example, a mechanical engineer who has joined the first year, he may switch over to the subjects which he may like, something like artificial intelligence, even in the third year also, in a 4-year degree course of engineering. So this is another revolutionary, I would say, provision given in NEP, and that goes good. The third point actually is for the, other than the professional courses like engineering, which are already 4 years, NEP says that the other courses can be actually be increased to 4 years. Now, at present, there are two types of courses or programs running. One is 3-year program, another is 4-year program, which usually will become next, few years about only 4-year program, but with an exit option after the 3 years. What is this? See, for example, a student who joins for BSc Science, let me say, and at present it is about 3 years in all the UGC recognized universities. This can be extended up to 4 years. And this extra 1 year which they are studying will be considered as a part of research or a part of master degree. So there is a provision, if a student would like to continue further, so within another 1 year, he can get his master degree, or another 2 years, he can actually submit the thesis and get the research also, PhD also along with it. So these are some revolutionary changes which we make. Another revolutionary changes which actually is being debated a lot is basically making these courses more interdisciplinary, in the sense that the students are made to learn, are actually given an opportunity to learn many other subjects other than the focused arena of course which he has registered for. For example, a mechanical engineer did not continue to study only mechanical subjects. Many options are given so that he can learn something about computer science, something about electronics, something about music, and also cultural, etc. and so on. So this is one highly debated, and also this has been taken as a positive and both negative by many people. Whoever actually try to put it as a positive thing, they say, look, the student actually, when he opts for a particular course or a particular program, his mentality status or his mental status may be having a particular understanding. But now, as he studies further and goes further, an option is given in NEP so that he can change the track of his learning, so that the entire field can be slightly modified and also fully modified also if possible, if the institutions provide him an opportunity. But NEP says that such opportunities be given. The critique on this particular system is you are making students, jack of all but master of none, something like that. You are actually teaching so many subjects and the students are not focused. See, for example, we say in a mechanical engineering BTech, we find that there are 4 or 5 verticals, something like thermal engineering, design engineering, and manufacturing, etc., and so on. And the people are made to focus on those so far. But now you are telling that the student can actually, also register for what is known as music, etc. So the focus will be slightly deviated. So this is the critique which actually is coming through. It depends on how do we, implement it and how the students enjoy these types of learning. So these are the overall gist as a part of NEP. On the overall, my opinion is NEP has created some sort of revolutionary thinking and revolutionary debates also on how the education, starting from primary education to higher education, be given. There are many very good points which can be immediately be implemented, and keeping aside the political aspects of looking at it, etc. I would suggest that NEP may be implemented in toto by all of us. And if there are any difficulties, of course, NEP itself gives a lot of freedom so that you can, fine tune yourself and go for it. One more thing which I just forgot, actually, NEP also gives a lot of importance for learning the mother tongue and the local languages. In fact, it says that professional education may be given or must be given in local languages also. There are again positives and negatives for it. Positives is basically because everybody actually who is brought up and born in and brought up in a particular local environment, it becomes very close to his heart. So everything will be easy for him to understand, rather than conversing in a unknown language, something like English. He may not be highly expressive. So this is one thing. Another one, already people are feeling that if placement is done or being done, or employment opportunities are being given only to the people who can communicate well in English. The moment actually you say that you are teaching them in your local language or vernacular language, then naturally the communication skills in English will come down, and that will actually reduce your employability. So these are the two things which actually people are also debating on. Okay, sir. So this is about NEP, and of course NEP actually gives not only for the STEM, that is science, mathematics, engineering, and technology. Now it has become STEAM. STEAM is science, technology, engineering, arts, and mathematics. So the art subject is being added. The whole idea why this art subject has been given is, for any person, there are two sides of the brain, left side of the brain and right side of the brain. It's understood that the right side has got its own functionalities to perform, and the left side also has got a lot of functionalities to perform. So when these two sides of the brains are combined together, then they can perform better. It's not that only mathematics alone can actually survive without the contribution from the other side of the brain, because other side of the brain may be actually giving a lot of importance for the imagination. So the mathematics coupled with imagination can take it further. This is so true for engineering also. Most of the engineering topics or subjects need actually both sides of the brain to work together. So this is another point in NEP.
Well explained, sir. The importance of NEP from kindergarten to higher education. And the other emerging topic of discussion is the language, the regional language, which you added into it. So now ICT is going for all the implementation of technical education in regional language. So as sir has mentioned, what will be the main problem is that communication gap will be there, as in the English is considered to be an international language, and employability and teachers adaptability also, the faculty adaptability also. If I am from Kerala, I will not be able to communicate a student from Gujarat. So all the, and some of the states are having 16 to 17 regional languages also. So it's a great challenge to be faced. So coming to the other side, we can see a lot of students now taking engineering, and their interest is becoming less nowadays. They're telling that why we are spending the 4 years, it's very difficult to learn all these subjects. We are failing. We are learning a lot of mathematics, and where we are going to apply. At the end of the day, I will be joining an IT firm, or I will be going abroad, or will be entering in some other field where this mathematics is coming, and I'm really fed up with learning a lot of these subjects. So what is this is a layman point of question. A lot of people usually ask where integration is coming, where differentiation is coming. So what explanation would you like to give from your point of view, sir?
See, basically, the moment we say that a student is joining engineering without mathematics cannot be imagined at all. Mathematics is the basic backbone. So before entering into it, the student should make his mind, or the student should have some flavor for mathematics, number one. But there are other subjects which actually we say mathematics need not be learned the way we are learning now. At present, the mathematics is being taught by mathematics teachers as a tool only. It is not having much of applications in the engineering part of it. So that is why the students, they start hating mathematics. And of course, even I learned mathematics in my engineering course like that only. The moment we start applying in regular life, then it becomes a very easy part of it. See, for example, a civil engineer, after graduating, he is actually going to the field, and if his boss says that, look, there is a tank here, the tank has got a trough, and the trough has got a particular profile. Can you estimate what could be the volume of the water that can be stored in a tank, or in a dam, or something like that? In such cases, very simple mathematics is very much required for engineers to understand how do we use multiple integration like triple integration. If I know the profile, apply triple integration and immediately you get it. And this is one part. The second part, usually what happens is, see, for example, you build a house. There are so many pillars. And these pillars, though we have the same pillar, all the pillars have the same strength or same dimension. A few pillars are loaded in future. Because, see, for example, if I see the veranda is not much loaded. The moment I see a living room or a bedroom or a kitchen or something like that, they are heavily loaded because of many other, household equipments which are actually occupying. But nevertheless, the strength of the veranda pillar also matters a lot because it takes part of that load into it. So it is something like this. Mathematics is something like a strong pillar. People should learn. But there are other, considerations which is going through. See, for example, a person who is studying, let me say, artificial intelligence and machine learning, more emphasis is given for probability and statistics in mathematics, because without that, artificial intelligence and machine learning cannot be learned properly. For them, the differentiation integration may be slightly reduced. So many universities have already considered that and are training like it. But there is a word of caution which I would like to tell the parents and students also. At present in India, there's a huge cry for only the CS-oriented courses, especially artificial intelligence and machine learning, because there's a great demand on it. But let me tell you very clearly, though there is a great demand, it actually requires highly efficient, personalities to solve those problems using mathematical tools. So if your mathematics is very weak, it is not possible that you can take machine learning and artificial intelligence as your career also. So this becomes one thing. Second one, I have seen a few courses in engineering who will actually curtail the learning of mathematics to only 1 year sometimes. Only in the first 2 semesters, mathematics will be taught, and other semesters actually it goes together. Let me talk about my own university. In my university, we are offering, that is Hindustan Institute of Technology and Science, we are offering varieties of courses both in engineering and liberal arts. Even in engineering, actually, for every branch, we have a set of mathematics tools to be learned together along with the mathematics knowledge. See, for example, very first year, we implement or we make the students to learn MATLAB. So they learn the MATLAB, they will learn how to actually solve mathematical equations using the built-in commercial software. So this actually helps them to solve the problem or apply mathematics directly for the application and then solve the problem, rather than going fundamentally into highly mathematical oriented derivation or solving, etc. and so on. So mathematics cannot be ignored, that is 100%, but it can be tuned, as you already mentioned. It can be tuned to the requirement. If a person says that, okay, now I feel that mathematics is not my cup of tea, of course he can take a deviation, learn something else. There are 2 types of design courses in engineering also. One design course, actually, it looks for highly mathematical learning, which requires, the contours to be understood, integrations to be considered, etc. and so on. There is another type of design. It is more of aesthetic. For that, these mathematical tools need not be taken as a base. It comes with, intuitively the skills which the student have, so they can go through. An example I will say, for example, if automotive engineer would like to design the body of a car, now he has a lot of imagination. These imaginations is something like, intuitive. A person will imagine a car in a different shape, he can draw some curves, etc. He doesn't need any mathematics for it. Now I'll come to the other part of the designer. The second part of the designer who will think that, okay, he is giving me the curve. Can I represent this in the form of equations or in the form of numbers or in the form of mathematical expressions, which can be fed to my, the manufacturing system, so that the entire curve can be replaced or can be redone. And that is where the mathematics comes into picture. And of course, you can also make many variations if you know the mathematics. So now, as you mentioned, a design engineer can take two roles. First role is basically looking at only the aesthetic part of it, highly intuitive, only the skill matters. So you can go and make a lot of imaginary things. The other person who looks at mathematics of these designs and then come out with mathematical equations and so on. So this is the answer for the question which you raised.
Beautifully said, sir. Actually, as sir has mentioned, mathematics is a great, good subject. The only thing, the teaching and learning has to be changed, or some add-ons has to be made, because whether it's STEM or STEAM, that aim remains same, mathematics, because the fractals, the visualization or the application everywhere, the subject, the modeling is so important. So let's go into this global connectivity. Now we are having a trend that students going abroad, or we need to have a collaboration with foreign universities or some tie-up programs where we can have a global exchange of thoughts, ideas, application, and job also. So what will be the vision of future India in incorporating NEP for a foreign collaboration? Like sir has mentioned, a lot of university will be coming, and how this foreign collaboration will be helping students in such an occasion.
Okay, let me just give a small tip of the history of foreign collaboration of universities. So far, Indian education was not actually open for foreign collaboration in terms of education. See, for example, even today also, IITs and IIScs are not permitted to open their centers abroad. And similarly within the country also, because there was apprehension that the quality of such things might be diluted there, or they may lose their focus. But now the trend is something different. And apart from that, many private universities or private institutions had collaborations with the abroad universities in a different or indirect manner. For example, they may say that I will have student exchange program, faculty exchange program, for which you don't have to take much of what is called UGC permission, except for the credits. If you take the credits which is earned by the student in abroad university, if you want to include in your thing, it was not permitted. Now NEP also permits it, but there are a lot of cautions which has been given. UGC has released a recent order which says that any university or institution who would like to have foreign collaboration have to follow a particular norm. The norms are, they say there should be an MOU made, and this MOU is actually taken care such that the universities in abroad are also of very high value. I think they should be within a particular rank. The university with which we are actually sending the students also should be of a very high value, so that nobody will lose, number one. Number two, the degree given will be by only the Indian university. See, for example, my university, like Hindustan Institute of Technology and Science, makes a twinning program with any abroad university, which is highly elevated in the abroad in the QS ranking. Then the degree will be given only by me, but part of the credits which the students earn from there can be implemented or can be borrowed and then put into my system. This is what the whole idea of abroad education. Apart from that, it also encourages a lot of exchanges of faculty from here to the next one, etc., and so on. So this is the gist of it. We can have a proper discussion as the meeting proceeds further.
Yes, sir. So it was a wonderful day and wonderful occasion to have visionary like you to share your ideas, giving a good clarity over NEP, the importance of mathematics, the visualization, the application, foreign collaboration. And at this particular moment of time, the admissions are going on, students having the result for +2 and the entrance examination. So thank you for joining this forum and exchanging your experience and ideas on your busy schedule. So thank you, sir, for joining. Thank you. Have a nice day.
Thank you, Professor Harikrishnan, for inviting me and having this discussion. Thank you so much. And you are doing a woman's work, beautiful work. Please carry on with this. Probably this type of discussions will be posted in YouTube, will help many parents and students also. Thank you so much.
Thank you, sir. Thank you.